Okay, I think we're ready to begin here. Thanks so much for coming today to another ICCF U.S. Congressional briefing. This is an extraordinarily hot day in Washington, and I know it's a Friday, so I appreciate everybody making a little bit of time to listen and discuss some of these critical issues. I'd like to first express my gratitude for Lee Schwan coming today. Lee, thank you for coming here to our swamp of Washington, D.C. I know you're leaving very soon to go back to South Africa, so I'm glad we could make time for you. And Drs. Monfort and Gratwicke from the Smithsonian Conservation Biology Institute, I think over at Front Royal. I know many of you probably have had the opportunity to visit some of the Smithsonian museums, maybe the National Zoo around town, but most people don't know that some of the world-class science in conservation does come out of the Smithsonian and their research institutes. So this might be a different side to the brick-and-mortar buildings that we're all used to with all the goodies inside. We also have a few representatives I know from ICCF's Conservation Council of Nations from various countries here today, so thank you for coming. And I'd also like to thank a few people, or recognize a few people in the audience here. We've got old friend Dr. Richard Ruggiero and Dr. Bagley from the Fish and Wildlife Service. I thought I'd find you by the cupcakes, Ruggiero. You're not usually one to pass up food. Julie McWright from Feld Entertainment, Kelly McGillicuddy from International Paper. I know I saw Rudy D'Alessandro here from the National Park Service. I don't think I've seen Barbara come in from SeaWorld Park and Entertainment, and Tom Greer from 3M, and last but not least, Michael and Susan Pillsbury. Thanks so much. I know you're about to leave for Beijing, so thanks for making a quick stop by on your way to the airport. We're here today to talk about the future of endangered species, and a lot of the topics that we've been recently covering at ICCF has to do with poaching, biodiversity loss, human-wildlife conflict, and these are very important. But this briefing today is something of a little bit more proactive than reactive, and I think what you're going to hear is from Lee Schwan is something very interesting on how to save species and reintroduce species into the wild, complete with all the political and economic challenges that you can imagine when doing something like that in China. So I'd like to, I think, first introduce Dr. Monfort to come and give us a little bit of a briefing, and then I bet Lee Schwan is going to discuss what Save China's Tigers is doing in the form of a species reintroduction. So everybody, please welcome Dr. Monfort.
Well, thank you very much. It's a pleasure to be here today representing my colleagues at the Smithsonian. So I'm from the Smithsonian Conservation Biology Institute, and just so to be clear for everyone, the Smithsonian is right here in town, but it's distributed all around the world. In fact, it's 19 museums, it's 9 research centers. We have about 6,000 employees. We're part federal. We're about 70% of our funding comes from federal appropriations, about 30% comes from non-federal funding. We're a 501c3 as well as a federal government entity, non-executive branch. I want to talk to you a bit about some of the science that we do to help save and recover species, and I'll give some examples of where we've done reintroduction efforts, but I wanted to emphasize some of the baseline work that has to be accomplished behind the scenes. We're talking about species being maintained in captivity, and the work that's required to make that a success. You need to have animals to do reintroduction. Ultimately, we're part of the National Zoological Park. Increasingly, SEBI is being seen as sort of the front door for conservation at the Smithsonian. We have the Smithsonian Environmental Research Center, the Tropical Research Institute in Panama, the Natural History Museum, about 200 scientists doing biodiversity and conservation science. But we have a mission of increasing and diffusing knowledge, and just recently they enhanced the mission by adding understanding and sustaining a biodiverse planet as one of the grand challenges of the institution. We're really the core group within the Smithsonian that has the sustaining piece when it comes to species survival and ecosystem work. So let me just jump right into it and talk about it. Why are we needed? Number one, first of all, the news is not particularly good for taxonomic groups. If you look at, does this have a pointer on it by chance? If you look at these, you'll see that the red indicates endangered species. Well, maybe I just,
the next slide.
Maybe I just turned it off. There it is.
Press the red button, it will
Okay, there you go. Perfect. Thank you. So the red is our species that are endangered or at risk of extinction, and you can see those numbers are very significant. So there's a lot of work to do, and those numbers are increasing all the time. The problem is not getting better, it's getting worse. So one of the things that we specialize in at SEBI is doing species-based approaches, and we work about, we say we save species on the brink. We use a species-based approach as sort of umbrellas for conservation. And those of you who don't know, I just wanted to just digress 1 second. Conservation biology, what the heck is that? What it is it's an interdisciplinary science that's based on the premise that saving biodiversity and maintaining functioning ecosystems for normal evolutionary processes is of benefit to human societies now and into the future. It's everything from developing legal frameworks and public policy to science and beyond. So it's a very interdisciplinary science. Our piece of it happens to be this species-based approach. And these are all species that we've worked on in one way or another that we've been helping to save and or restore to the wild, and I'm going to give a few quick examples of what we've been doing. But we are, from a zoological point of view, we are part of the National Zoological Park. And so if you look back at the history of zoos, they were really these menageries. They were places of public entertainment, functionally living museums. And over time, they've evolved into this conservation center approach. There's about 214 accredited zoos just in North America. In our mind, we're out here, we believe we're out here at the tip of that spear. We're trying to redefine what is the role of a modern zoo, what is the business of a modern zoo. And in our mind, the business is conservation. And so we're actually trying to take our 3,200-acre facility in Front Royal, Virginia, and our zoological park in Washington, D.C., and leverage those resources to maximum effect. But I want to talk about, eventually, reintroduction. But if you're going to do reintroduction, you have to have animals to be able to reintroduce. And as populations start to decline and numbers become small, it becomes quite a challenge to actually sustain the genetics and the demography of these small populations. So I mean the age distribution of the population and their genetic diversity. If I took all these people in the room and I put you on a desert island and I said, you're all the gene diversity that will exist forever, from now on for the human race, we could probably design a paradigm that would make sure that we maximize the diversity in this room. We could have a pedigree analysis, we could do a computer program, but if I started matching you up for breeding, you might not like the choice. You might not cooperate with the choice. And over time, what would happen is somebody would die unexpectedly or they'd fail to reproduce, and that founder lineage would be lost. And so what you're trying to do is maintain maximum genetic diversity for periods of hundreds of years. We think about problem solving in terms of decades and our lifespans and whatever. We're talking about forever, thousands of years, 10,000 years. Imagine the challenge of keeping gene diversity and demography for 10,000 years, not just 100 years. So these are examples of species that zoos initially had great success with. Just pay attention to the blue line. And that shows the number of animals. There's only about 300 Persian onagers left in the world. Zoos did a very good job with them through the 80s, and then we shut down reproduction. We ran out of room. And so when we tried to turn reproduction back on, it didn't work. And so the numbers started to decline. Same thing with sable antelope. Went up, and then they crashed. Pear David's deer went up, and then they crashed. Why is that? Well, zoos are not designed to be breeding centers. They don't have extra space behind the scenes. They're not designed to be conservation breeding facilities. They're designed to be postage stamp collections, ARC collections for you to enjoy when you come to the park. Cheetahs, we've had them in captivities in human hands for thousands of years, and yet we still don't know how to maintain them in sustainable numbers and healthy. This is just in North America. This is the number of births over through the end of the mid-2000s, and you'll see that the number of births is lower than the number of deaths. So the population is still declining. Despite all of the knowledge and the science, we're still taking animals out of the wild to maintain captive stocks. If and when we need to do reintroduction in the future, that's not a good sign. So why is that? Well, one of the reasons is we don't have the right infrastructure. And so places like SEBI in Front Royal with 3,200 acres, we set aside specialized facilities for breeding, for conservation management, and for science. And so these aren't just simulated habitats. These are just for clouded leopards, one of the rarest Asian cats, red pandas also. And this is just facilities dedicated to maximizing well-being, the ability to do science, and to facilitate conservation breeding. There's only 5 places like this in the United States, and this is the only one that actually has the number of scientists and space and expertise all mixed into one. We need more places like this if we're serious about using captive stocks for eventually doing reintroduction. Our cheetah science facility, through a 125-year history of the National Zoo, we had 2 litters of cheetah. And so everybody thinks, oh, wow, cheetah, it must be easy to breed. We see them in the wild. We see them on TV all the time. They're incredibly hard to breed in captivity, and they have all kinds of health issues. So we've constructed an 11-acre facility. It's dedicated just to cheetah breeding, and in the last 2 years, this is a 4-year facility built for about $1 million in private money. We've had 4 litters of cheetah in just the last 4 years, actually in 2 since we got up and going. So if you give cheetahs what they need and you do the science and you do the husbandry, you can have a big success like this, a litter of 5. So that's progress, but it's not because the progress requires, science. It requires knowledge. The time to do the science is not when you have the last 12 or 14 animals left on Earth. And there are cases I'm going to talk about where that happened, and here's one of them. The black-footed ferret from the American West. They were thought to be extinct in the early 1980s. A rancher's dog brought a dead one home in his mouth. The dog's name was Shep, believe it or not. The rancher got the extension agent to identify it as a black-footed ferret. So they went out into the wild, and they captured the last 18 individuals, brought them into captivity, and started a breeding program. And just like I said, not all the animals the founders wanted to breed, and you had incompatibility, behavioral issues, and so they turned to us and asked us if we could develop workarounds. And a workaround was assisted breeding, artificial insemination. So we started a program where we did that, developed it using domestic ferrets as a model, and a number of research projects. And now, since 1987, there's been 6,000 animals that have been produced, about 450 or so, maybe it's 500 now at our facility, and about 125 or so have been produced by artificial insemination. That's bypassing behavioral incompatibility to produce offspring. And now all the representative individuals left in the world of this species, and they're in 7 sites reintroduced in the United States, Canada, and also in Mexico, are only descended from 14 individuals. So they came to us with only 18 left. We pulled everybody working together, Fish and Wildlife Service, all the partner agencies and zoos, and came together and pulled a rabbit out of a hat on this one. But this is not the way, really, that one would think about doing it. This is the kind of work that we did in a systematic way over a number of years, starting with natural breeding, developed AI. Finally, we're successful. We developed this system of pre-release conditioning where we built prairie dog towns in the back of the ferret's enclosure. We allowed them live in there, introduced prairie dogs, let them learn to kill, and that became part of the standard pre-release protocol. So we've done a holistic approach. We went out into the field. We were part of the team that did the biomedical surveys, assessing the animals in the wild, finding out what were they susceptible to after they had been released, what were the vaccines that they were being given working, and so on. So a whole bunch of science went into making this project a success. And I'll finish by saying we collected sperm from a couple of the original founder males more than 20 years ago, and just in the last couple of years produced offspring from frozen thawed sperm after 5 or 6 generations, which is, if you think about that in human terms, it's a very long time. So it's high-tech, but it's a combination of high-tech, low-tech, common sense, husbandry, and science all put together. Giant pandas. You know about giant pandas. They're really cute. We have them, have had them since the 1970s. But we've been doing science on them since the late 1970s and have made a lot of progress. Right now, the focus is on saving animals in the wild, but ultimately there may be reintroduction. In order to do that, you have to have animals that are, you have to have enough animals in captivity of the right gene diversity and a stable demographic pattern to be able to afford to release, take them and put them into release programs. In San Diego Zoo and the National Zoo and others came together, and as part of our enhancement programming and the funding that we gave to the Chinese for the enhancement payments, plus our own money, we conducted additional research in all of these different disciplinary areas, and we did a lot of capacity building. We've trained over 500 Chinese professionals, and the results today are that there are a growing population of giant pandas, an exponential growth in that. The population has now reached this 300 milestone. They've now just recently increased that target to around 400 animals, and they're making plans to do reintroduction programs. So this all has to happen before reintroduction can occur, and it takes a couple of decades to do this. And there's only so much money in science, but if you have an interest and you have the funding and the support, it can be done. The golden lion tamarin, it's a flagship program of the National Zoo. It's a species from the coastal Atlantic rainforest of Brazil. Populations were declining. We took this on as a project with these goals. We wanted to increase the diversity, genetic diversity and stability of the wild population, protect their habitats, expand their habitats, and conduct science and educate the public about what's going on. This is now the largest global stud book of any species in the world, and we had a long history of success with it. We did, for those of you maybe have seen in the previous years, we had a pre-release training program within the zoo itself here in Washington. We had the same type of a program in Brazil. You know, building capacity and training and collaborating and partnering are a huge part of what we do. But through that process, it's been very successful. And now the wild population has grown to around 700 animals on the backs of about 150 or so that have been reintroduced. So virtually all of the animals being born today are wild-born. But it was really supported in great part by this reintroduction. And now we've moved it into private hands. There are reserves that are being created. There's now 32,000 hectares that are set aside for their conservation of the golden lion tamarins. In 2003, they were uplisted from critically endangered to endangered. So this one is a success. I just want to say, when I just said the word success, what do I mean by that? An outcome. And we say the outcome is X, Y, and Z, and we can declare success. The thing that we have to remember, I already alluded to it once, is this isn't, you don't just claim success and walk away. This will have to be managed forever. And it's just really a hard concept for us to think about. We think, oh, we did it, they're back in the wild, they're safe. Until the next catastrophe, the next disease pandemic, until the next, whatever happens. This is going to be it's going to be generation after generation after generation dealing just with golden lion tamarins. Multiply that times thousands of species, and you can see the scale and the scope of the problem. I want to finish by talking about one project we're working on now. Brian Gratwicke is really the lead of this project, but there are a large number of amphibians, thousands of these frog species, not only frogs but salamanders and others, and this is a 43% decline in amphibians has occurred in the last several decades. And if you look at this number, 32% threatened as compared to birds, 12%, or mammals, 23%. Just since 1980, 168 species, we think 122 since 1980 have gone extinct. That dwarfs the extinction rates of any other taxonomic group that we know of that we're counting. There are probably many others that are probably extinct, those that are data deficient. Basically, species are going extinct before we even identify them by name. So these are some incredible, beautiful frogs that we know of, and every single one of them is extinct. And so it's a lost opportunity for mankind in terms of biodiversity. These are the proverbial canaries in a coal mine, if there ever was one. Their skin is very sensitive to chemicals in the environment. They are really an indicator species for the planet, and they're a species that taxonomic group that's in great trouble. So what is the problem? One of the things responsible for this enigmatic decline in amphibians is this emergence of this fungal pathogen, this chytridiomycosis. This I won't even pronounce that. That's the genus species name. It was actually discovered at the National Zoo in the 1990s in a zoo collection, and since then it's been identified as the culprit for spreading around the world. The world is flat, and these frog legs are traded, and animals are traded for all kinds of different reasons, and the pathogen will move, and it's moved around the world. It's been traced in Latin America as in this way, moving down towards Panama. And there's one population we knew of. We knew that this was moving at around 30 kilometers per year. And the idea was, if we could get to this area and we could rescue the amphibians that were there, perhaps we could figure out a way to mitigate the impact of the fungus and reintroduce those animals before they go extinct. But get them before they go extinct with the possibility of finding a cure and doing reintroduction. So this is the work that we've been working on in Panama, in this Panama Amphibian Rescue and Conservation Program. It's a partnership between a lot of different zoos and also the Tropical Research Institute. Here, the team went out into an area where we believed it was the last site for at least 5 species of frogs, and those frogs are then brought into these rescue pods, which are old shipping containers. And these literally are the closest thing to an ark you can imagine. They're outfitted with these terrariums and some pretty basic husbandry setups. And the idea then is to develop sustainable populations. These are the species that we're working on as a priority right now. We're going to target up to 30 species to try and rescue over time. But this, look how, I mean, they are really incredibly beautiful and valuable species. But the challenges of keeping them in captivity, again, are incredibly challenging. You take a species out of the wild, you have no idea even what its husbandry requirements are, how much humidity is required, what are the conditions under which they mate, what is their diet, what is their preferred diet, for example, what are their needs just to keep them alive. Then you have to figure out all the other nuances of reproduction. Then you have to identify animals. You have to maintain them in some sort of a database so you can identify genetic diversity, demography, all of those things I'm talking about. It's very complicated, but it's totally doable. With the right amount of support, it can be done successfully. And what we're doing, one of the things that we're pursuing is a cure, and we know that it's been shown, preliminary data has shown that some types of probiotic bacteria that live on our skin or in the skin of frogs, in this case, actually provide protection. They confer protection against pathogens that attack us. If we didn't have healthy bacteria, we'd pretty much all fall apart as humans. The same thing is for frogs. So we're trying to identify the species of bacteria, we're doing bacterial bioprospecting in Panama with a large grant and trying to identify a candidate bacteria that can then we can incubate with the frogs and let it grow on their skins and do challenge experiments to see if we can actually identify a way to inoculate them for reintroduction. If this doesn't work, we're going to keep trying to find other ways to go, but it's one promising avenue that we're pursuing right now. So this isn't just an idea of bringing them into captivity, keeping them in aquariums for the next 1,000 years. This is an idea of, this is triage. We get them in, we stabilize them, we try to do reintroduction. What do we do at our own storefront? We are trying to create, inspire learning and empathy in young people. We're reaching out to the public, the press. We have a web presence. You can go to our amphibianrescue.org. You can go to our Facebook page. These are just a few of the examples of species that we're dealing with. SEBI has about 220 people working in 25 countries around the world, working on a couple of dozen different major species groups. So I hope I've given you a little bit of a flavor for it. I want to just finish by saying, the theme was reintroduction, and so I just wanted to mention some of the things that I'd already really said, that you can't ex situ, or what we do with captive animals, is as important as what we do with the wild situation or with reintroduction. The two have to be partnered hand in glove in order to make a successful program. Even after you do the reintroduction, you have to maintain that insurance population in captivity defend against a catastrophe. So it's the ultimate insurance policy. These kinds of reintroductions, they're risky. You know, it's not for the people with weak stomachs. A lot of animals will perish on reintroductions. They're high mortality rates, high failure rates, but in many cases, it's really the only way to go. They're expensive, and they require a long-term time horizon. It's not something where you do it once or twice over a period of a couple of years. You're going to have to be in it for the long haul. The longer we wait to do reintroductions, the less chance that we're going to find viable habitats and functioning ecosystems to put the animals back into. And then the longer we keep them in captivity, the more chances that they're going to lose their adaptive ability for living in the wild, which is another thing people are studying. And I just can't overemphasize this enough. The absence of knowledge, assumptions that we know everything there is to know, are so overhyped in the media about everything we know about assisted breeding, let's say in humans, and cloning. And it's so hyped up and it's so much garbage. There are, of the mammals alone, 5,400 mammals. We have detailed science information of about 300 mammal species. That's it. Out of 5,000. Forget the other ones, the birds and the reptiles and the fishes and so on. So absence of knowledge. We need more fundamental science directed at species that are not farm animals, not lab animals, and not humans. And so this is this other thing. Try to get your head around the concept of a never-ending commitment. If we plan to be here for 100,000 years and have lions in the wild and tigers in the wild and all these animals that we think make the world worth living in, it's going to require a multi-generational forever commitment. Okay, thank you.
Okay, now I'd like to introduce Li Xuan, who's a founder and runs the Save China Tigers program to specifically address some of these issues in relations to her experiences with tigers.
Good afternoon, ladies and gentlemen. Welcome to my presentation. I would like to thank Dr. Monfort for his wonderful presentation, which really lays out the background for what I'm going to talk about. And you see there are a lot of work done for breeding up endangered species, and there also have been some successes in China as well. For example, with the Pravorsky horses and the crested ibis, and another thing is Davis deer. So, but today, what I'm going to talk about, I'm going to focus on a predator introduction, which has been very controversial simply because it's a totally different scenario as well. For predator introduction, broadly speaking, there are two kinds of introductions. One is straightforward translocation. Basically, you translocate certain animals that's endangered or not endangered from one area to a new area where they have gone extinct. And this is fairly easy if they have enough individuals. And the second scenario basically concerns a species that's very endangered. They might not be found in the wild. And in that case, you cannot just even take zoo animals and dump them into the wild. You have to go through an extra stage. And this is the extra stage that I'm going to talk about. Okay. First of all, I'd like to give you an idea on what the South China tiger is, because a lot of you have heard about Bengal tigers or Siberian tigers. The South China tiger is least talked about. However, in terms of conservation, it's probably the most significant. The reason is the South China tiger is actually the ancestor tiger to all tigers on this planet. Practically all tigers that you know, whether they're purebred or not, are descended originally from the South China tiger, which originated in China 2 million years ago. And it also has been Chinese culture for thousands of years, and the earliest record was about 8,000. And obviously, if you're involved in conservation or biology, you know that South China tiger, or the tiger, is a flagship species. If the tiger is gone from its habitat, it means that the habitat may get lost for other species as well. And this is really what happened in China. So our project, Save China's Tigers, to rewild in order to introduce the South China tigers, basically touches on 3 different areas. One is environmental development, By environmental development, I actually mean biodiversity. Dr. Monfort talked about the biodiversity loss. Once you lose the land, the biodiversity, if you don't reintroduce, you're going to lose the land and eventually you're going to lose the habitat. So what we're trying to do actually through the South-China Tiger Rewilding and Reintroduction project is really to aim to gain more land for wildlife. But it's more difficult to convince people we need to gain land for antelope, for deer, but it's easier, relatively speaking, to gain land for an animal that people care. In this case, which is a cultural symbol of China. And then the second environmental aspect is we need to breed and rewild the tigers we do have. Since the Southern tiger is highly endangered, there are less than 10, if at all, in the wild. What we have now is really captive population. But as I said earlier, you really can't just dump a captive population directly to the wild. You really have to go through an interim stage. The reason that they have to go through this interim stage is that in the wild, a feline or predator, in this case a tiger, spends up to 2.5 years with their mother to gain that ability to survive in the wild. And that ability is not just like hunting, but also the ability, for example, to avoid dangerous game and to be able to breed and feed your offspring. I just had a case last week. One of our tigers probably must have been tampering with fire, and he got some porcupine quills on his throat. Now, that's very dangerous because porcupines are known to kill cats. So this is kind of danger that they face in the wild and the kind of thing they will have to learn through the rewilding process. And economic development, through Save China's Tiger projects, we actually aim to bring sustainability model to China, because traditionally conservation has been done by the government, and if the government has enough funding, some species will get some funding, but in bad years, the amount of money that goes into conservation is very, very little. And what we try to do is to create a model, the model that I have seen working in Africa, in particular ecotourism model, to bring to China. So in order to make conservation sustainable, that means you get animals, the wildlife, to pay for themselves. You pay the local community, because the local community will gain through tourism, through jobs created through tourism. And innovative finance, we have to, we know conservation is very expensive, particularly a rewilding breeding project that Dr. Monfort has also mentioned. So we need to have a substantial amount of funding. And it was not enough to raise money just from the public, even though we're registered public charities in many different countries. So we have to support the project through business. And that's something that we have been, that's why we've been able to support this project. And social development in terms of capacity building. China lags behind in conservation expertise, and that's not a surprise because conservation started fairly late. And so one of the things that we try to do is to train Chinese officials as well as ground workers in conservation. For example, we bring them to South Africa and let them see what South Africans do on the ground and see what we do on the ground. And we also want to provide economic opportunities to the local communities involved in conservation, because if they don't get involved, they're not going to support tiger conservation or any conservation at all. I just want to briefly touch on this slide. And as you see, this is done by a group of scientists at the Stockholm Resilience Center. The planet has certain boundaries, and once we surpass certain boundaries, we may have reached the point of no return, and that means we may not be able to save certain species or certain reverse damage. In the case of the planetary boundaries that we have surpassed, the worst right now is actually biodiversity loss. The background loss of species right now is between 100 to 1,000 times more than normal. And the same thing, applies to tigers. There are 9 subspecies of tigers, and 3 have gone extinct. And the next one to go extinct is the South China tiger. In fact, when I started the project in 2000, there had been predictions by certain conservation groups that the South China tiger will go extinct by 2010 if nothing was done. And so let's look at the numbers. And the number of tigers, 100 years ago, there were 100,000 throughout Asia in tiger range countries. What's interesting with that figure is that in 1950, in a matter of 50 years, the tiger numbers have dropped to 40,000. So 60,000 disappeared between 1900 and 1950. In China, the cause of that demise was actually chaos. China went through a period of incredibly unstable time, internal wars, anti-Japanese wars. So China lost 36,000 tigers between 1900 and 1950. During the unstable period, many people started moving into the interiors of China, basically taking over the last habitat in which the tiger lived. And we would compete for resources, for food. And it would also, kill the tigers themselves in order to take over the land. And then what happened next for the 4,000 tigers left is that when the Chinese Communist Party took over, and because it's a party made for the people, the farmers started a campaign trying to eliminate predators that pose threat to their lives. And therefore, there was a mass campaign to eliminate what we call 4 pests. It includes tigers, leopards, wolves, does. And obviously, such elimination of wildlife happens all the time and still occurs now in South Africa, where I am. My neighbors continue to poison, the caracals, the bat-eared wolves, and we often have to save the babies of orphans if we found them. However, if you can imagine, in a country with a lot of people, when it's an organized campaign, it's very effective. So by 1980, the number of tigers dropped basically to nearly nothing. We continue to say that we have 10 to 30 in the wild, maybe, because simply from time to time we continue to get report that there may be wild tigers, wild South China tigers. So in this dire situation, what do? We can't really find wild species, wild South China tigers, and we had very few captive South China tigers, and they were not doing well in zoos. As Dr. Monfort pointed out, that's one of the things, once they reach certain numbers in captivity, and their numbers drop again because of environmental problems. And in Chinese zoos, when I started the project, the breeding rate was very, very low, and there were a lot of deaths and a lot of illness as well. So the South China tiger is critically endangered and the only one available for introduction. However, basically rely on these captive animals. And what do we need to do is to actually take them out of zoos, take them out of captivity, and put them into a natural environment to see if they can gain back their ability to survive in the wild. So this is a really critical stage before reintroduction for predators. And for any predators, really, because all predators need to acquire that skill to survive in the wild. And that just doesn't come naturally. They may have the instinct to kill. Anyone who has a cat will know you throw a ball, the cat goes after it. However, to translate that into the hunting ability takes a long time. So what we have done is we have done something quite unusual. But this is not really unusual if you, have listened to what Dr. Monfort said. There are a lot of ex-situ conservation where animals are taken out of their natural environment and then bred in a totally different place. And through cross-border collaboration, we're able to resurrect, for example, black-footed ferret and Davis deer and Privosky horses. So for the South China tiger, what we have done is to use South Africa as a springboard to fast-track this, what we call rewilding process. when I first started this project, we couldn't find the word to appropriately translate the Chinese word 野化. 野 means wild, 化 means the process of becoming wild. So in the end, our strategist, Gus van Dijk, who's a carnivore manager with Pilanesberg Park National Park, he just said, why don't we just use rewilding? So now rewilding is being used for predator rewilding as well. And South Africa has other advantages because it started wildlife conservation pretty early. It has a huge number of wildlife managers, and that could help to achieve our goal. And another advantage is availability of land and also prey. And obviously, we are actually not the first one that started the South China Tiger rewilding project. The first one was started by China. However, due to all kinds of limitations, domestic prey, domestic stock we use in rewilding. So the tigers never really learned to hunt. It's a very different thing chasing after a duck or a chicken than chasing after a wild antelope. And however, all of this, anything we have done in South Africa is really to aim to bring the tigers back to China. We simply use South Africa as a springboard to quicken the process. And our next challenge is really to develop reserves in China to which the tigers can be returned. But before we do that, we actually need to select appropriate sites. We all know it's a challenge in China with 1.4 billion people still growing, even with one-child policy. And we need to find a site that we can spare for the tigers. And then we have to introduce prey. And reintroduce the prey should be a straightforward process. We have done that in South Africa as well, and South Africa has translocated, thousands and thousands of heads of animals. It's a big success story, and we can do the same thing in China and get the reserves ready before we reintroduce the South China tiger back, the rewild South China tiger back. So what we have done, and this you can see here, this is Madonna, and she was in Chinese Zoo at the time. And we translocated 2 pairs of tiger cubs from Chinese zoos, plus an adult later, to South Africa between 2003 and 2007. And they really got real VIP treatment. They got a private little charter plane by a friend of mine from the Johannesburg airport to our reserve. And this is the Laohu Valley Reserve. Laohu Valley Reserve itself was actually restored from 3,000 hectares of defunct sheep farm. 17 farms were acquired. And they were really overgrazed, and we tore down the internal fences and built a new reserve. However, we're not using the entire reserve for the rewilding project. We're basically we build camp systems. And there's certain reason for that, because once you actually provide the tiger with a number of game to hunt, by the time the tigers hunt down the game, let's say we introduced 20 in a rewilding camp, and they will start hunting. By the time the numbers reduce to 5, it becomes very, very difficult to hunt. So they regulate the difficulties of hunting themselves. And this is our infrastructure, and we have electrified fences. So tiger learn early on when they come in touch with electrified fences not to touch them. And they can't resist that urge from time to time because they hate it. But they're smart that they will learn to stay away. And we have river into the camps, so it simulates the wild habitat. So if they feel the heat in the summer, they will go soak in the water. Rewilding has been enormously successful. Out of all the first generation tigers we brought from Chinese zoos, all have learned to hunt. And then the first tigers born in South Africa 4 years ago, 3 years ago, they also learned to hunt. And what we really do is we go through the system as if they're in the wild. In the wild, for example, the mother would take a little antelope or little deer back for them to play. And through this play fight, they eventually get the hang of it. They will learn that the thing they've played and killed is actually their food. So as they progress and their size grow bigger, we give them bigger game as well, and slowly they will actually progress to kill the bigger game, or to hunt the bigger games. cats always have the killing instinct. But to actually link killing to food is one thing, and to also actually to be able to acquire the skills of hunting is another thing. And hunting requires a lot of time, to learn. But so far, we've proven that this can be done. And another important aspect of rewilding is actually breeding, because the tigers, having lived 10 generations in Chinese zoos, having had enormous problems breeding, we weren't sure whether they'll be able to breed at all. One of the problems is the genetics. We weren't sure if they would be breeding with us. But I also knew that the tigers weren't happy in Chinese zoos. Therefore, giving them a natural environment, they may decide to do something different. And so all the tigers that came from China ended up breeding with one another. And this is the first pair of tiger cubs born in complete natural environment, raised by the mother, Madonna. So having basically, the project has been going on for 9 years in South Africa, and we have really proven that the tigers can learn to hunt even though they have passed 10 generations in captivity, unlike what some people have predicted, and they basically say, once they're born in zoos, no way they're going to learn to hunt. We've proven otherwise. And all tigers basically have bred. All the tigers came from China, bred, and we're on to next generation of breeding, basically between the tigers born in South Africa. And we have now 14 tigers under our care, 11 were born in South Africa. And all of them, except the newborns from last year, are ready to go back to China. So China is our next challenge, and it's taken much longer than expected and than I wanted to. I knew I was a little bit too ambitious, and the Chinese government officials we work with were a little bit too ambitious, but hopefully we're getting there. We have scientists from overseas, including quite a few American scientists like Dr. David Smith, Dr. Gary Kohler, have been to China. We've been working with the government, trying to identify the suitable sites. And, after the site's approved, then we can start the restoration work of these sites. And, we hope that we will succeed probably next year. Anyway, that concludes my talk. I would like to thank you for listening to my presentation. Thanks ICCF for organizing it, and thanks for the Smithsonian for co-presenting this very important subject, which many believe will be the future for conservation. Thank you.
Thank you, Lee. I think we have a few minutes for a few questions, and if anybody would like to say afterwards, I'm sure our speakers would be more than happy to also answer additional questions. Are there any questions that anybody has? And if you wouldn't mind also stating your name and office.
I'm Jacob with Congressman Latham's office. I was wondering, did you say that all of the tigers born in South Africa were from the same female?
We have actually 2 males and 2 females, and so the tigers are from all of them. And what's remarkable about this is that in Chinese zoos, I have their internal record, and we compare the breeding success. One is heaven, one is hell. Truly, in one of the tigers, for example, we have it's called 327, which was unfortunately killed last year by Tiger Woods. But he was reputed not to be able to breed, and he ended up breeding anyway. So you can see what the environment can do to help this tiger recover. And he also got, one testy. And so even with that situation, we're able to breed. So all of them are from 4 different founders.
I'm Blake Smith from Senator Heller's office. I was wondering, why would you bring him out of China into South Africa? Why wouldn't you just keep him in China?
Well, actually, initially, the Chinese government started a program in China. It's in Meihuashan, and I was actually supporting that as well. But I saw a lot of limitations because, as I mentioned earlier, there's no land. There's a very small area in which they were training the tiger to hunt, and they were using the wrong prey. They were using domestic stock, so you're creating more problems. If the tiger learned to hunt domestic stock, if you reintroduce them back to natural environment, they're going to go after human stock again. So also, China doesn't have the expertise in terms of wildlife management, not to the degree that South Africa has. And that's why I decided to persuade the government to let us do this in South Africa.
Can I ask you both a question about the budget, your budgets? Li Chuan, you didn't mention anything about the U.S. government. Has anybody helped you from Smithsonian or Fish and Wildlife or U.S. Forest Service, or you've had no contact with the U.S. government until yesterday when you went to the Bob Hormatz's NGO summit? And I wanted to ask Steve the same question. What approximately how much does the Front Royal facility cost? And my real question is, based on someone Susan and I know from Tanzania. She's a Yale PhD who has actually saved a lot of lions, and she has a dollar figure for how much it costs to save one lion for life. And she's been able to show this at National Geographic especially, that if you build a $500 fence, I mean, this doesn't apply to tigers, but you build a fence around the cows and so forth for $500. Over time, this translates to X number of lions saved. Have either of you done this kind of calculation, or is it really for financial people to do this kind of calculation?
First of all, I can tell you we get a federal appropriations out of the Smithsonian for science for SEBI. $6.2 million for about 60 federal government employees, and that 60 employees becomes 220 employees based on grants of about $6.5 million a year. Currently, we raise about $2 to $3 million in philanthropy that's based on science. So, on the back of $6.2 million in federal, we bring in about $8.5 to $9 million additional. So that's what our budget is, pretty modest, about less than $15 million a year to deploy the scientists that we have. The zoo is additional, for the care of the animals downtown. That's a separate charge.
Each cheetah cub born.
We estimate about $5,000 per year for us to care for, maintain, do science, and breed a cheetah. And one of the things we're trying to do with the zoo community is to say, the model that you've been working on, the business model of if I build a facility, I'll share animals, you'll give me a cheetah for free, is not a very sound model, that there are real costs to doing these things. And we're trying to build a model that says you have to pay to play. Ultimately, the rarer the animal is and the harder they are to sustain in terms of their production, it's going to cost money to do that. So the price of doing business for zoos is going to go up over time. And those that accept that and get on board are going to be in a better position than those that don't.
Yeah, it's a little bit complicated answer, but because we have been sort of like contributing our private fund to the charity. So we set up Save China Tigers, but raise some money, but most of the money come from our private, business and also savings at this moment. We did collaborate with U.S. Fish and Wildlife during the initial stage of the South China Tiger project. We did survey in China that was funded by Fred Bagley of U.S. Fish and Wildlife, and also we trained the Chinese trainees in Thailand to do capacity building. And so now we're talking again, hoping that U.S. Fish and Wildlife might be able to participate in the restoration of habitat in China. In terms of South Africa, it is very expensive. If you can just, for example, imagine one tiger needs to eat one antelope every 4 days, and one antelope costs between $150 to $200. and never mind the staff I need to actually, monitor the tigers, the scientists we need to, analyze data, and also the fences. Now, for example, we're building another rerouting camp of 100 hectares, and the cost of that is about 60,000 pounds. And, that it's still expensive because the Chinese, steel prices more than doubled in the last 10 years since I started the project. So our annual budget in South Africa is between something like $350,000 to $600,000, depending on the year.
Okay, well, thank you all so much for coming on this Friday, and I look forward to seeing you all in the future. And if anybody would like to stay for more questions, and I'm sure James would like to not have to carry all these cupcakes back. So if you could help us with that as well. Thank you.